Good morning, everyone. I am Christine Cantas, and today I will be discussing my own model, which is the symmetry sphere model. This symmetry sphere model came from the word symmetry from symmetry, emphasizing balance and mirror-like structure, and sphere hints at the balloon's rounded 3D shape. As you can see here, we have the front and back figure. In the front figure, we have the elements S, Y, M, E, T, R, A, N. And in our back figure, we have the elements 0, 1, 2, 3, 4, 5, 6, 7, where these elements correspond to different moves. Now, I'll be showing you how these moves works. For element letter S, we will just do nothing. For element letter Y, we will rotate it by 45 degrees counterclockwise. Element letter M, we will rotate it by 90 degrees counterclockwise. For element letter E, we will rotate it by 135 degrees counterclockwise. For element letter T, we will rotate it by 180 degrees counterclockwise. For element letter R, we will rotate it by 225 degrees counterclockwise. For element letter E, we will rotate it by 270 degrees counterclockwise. For element letter N, we will rotate it by 315 degrees counterclockwise. This time, let's try to operate the element letter S to all elements. So in here, we have S star S is equal to S, Y star S is equal to Y, M star S is equal to M, A star S is equal to A, T star S is equal to T, R star S is equal to R, A star S is equal to A, N star S is equal to N, O star S is equal to O, A star S is equal to 1, 2 star S is equal to 2, 3 star S is equal to 3, 4 star S is equal to 4, 5 star S is equal to 5, 6 star S is equal to 6, and then lastly we have 7 star S is equal to 7. Next, we proceed to element letter Y. So, okay, we have a typo here. It should be X star Y, okay? So, we have here Y star S is equal to Y star Y is equal to M, Y star M is equal to E, Y star E is equal to E, Y star T is equal to R, Y star R is equal to A, Y star A is equal to N, Y star N is equal to S, Y star 0 is equal to 1, Y star 1 is equal to 2, Y star 1 is equal to 3, Y star 3 is equal to 4, Y star 4 is equal to 5, Y star 5 is equal to 6, Y star 6 is equal to 7, and then lastly, we have Y star 7 is equal to 0. So in order to complete the table, we just need to do the same process, just like what we've done doon sa element ng S and Y. Now, we can say that this table is closed because all elements stay within the sets. Now, let's check if this table is associative. So, para malaman natin kung associative ba siya, kailangan natin i-rotate yung table by 180 degrees. And then, kailangan din natin interchange yung rows and column kung possible. Ganun lang. Now, let's try it. As you can see, naka-rotate na yung table dito. So, kailangan na lang natin is mag-interchange ng rows and columns if possible. So, dun sa pag-interchange natin, dito sa result na to, as you can see, nakuha natin yung same result gaya nung sa ating original table. So, therefore, we can say that this table is associative. Now, let's check the identity element. So, by looking at our original table, we can conclude that S is the identity element because the row and column labeled S both reproduce all elements in the same order as the set. This means for every element X in the set, S star X is equal to X and X star S is equal to X, satisfying the definition of an identity element. Now let's move on to the inverse element. So lastly, by looking at our original table, we can say that each element has an inverse because for every element X, there exists another element Y such that X star Y is equal to S and Y star S is equal to, or X rather, is equal to S, where S is the identity element. So this confirms that all elements have inverses in the set, like these examples. Based on the operation table, we can conclude that the set forms a group under the given binary operation. This is because the operation is closed, as all results stay within the sets. There exists an identity element, and there's also inverse element exists. And lastly, the operation is also associative. Therefore, all groups' actions are satisfied, confirming that the structure is indeed a group.